Consider the following reaction. SO2-Cl2 gas goes to SO2 gas plus Cl2 gas. The K sub C value for this reaction at 225 degrees Celsius is 2.99 times 10 to the negative 7. What is the concentration of Cl2 if the mixture originally has 0.195 molar SO2-Cl2? For this problem, we are going to put into effect what we just talked about in the previous slides about the X's small approximation. So first, what you want to do for this problem is to set up an ice table. So you can rewrite your reaction to make it a little bit easier. SO2-Cl2 gas reacts to form SO2 gas plus Cl2 gas. Set up your table. It'll be your I, C, and your E columns. So initial change and then equilibrium. So right here it says in the problem we start out with 0.195 molar of the SO2-Cl2 gas. And since it doesn't say anything, we automatically assume that these are both 0. And then you want to go to your change. So this one is going to be minus x, plus x, plus x. And then down here for equilibrium, it'll be 0.195 minus x, 0 plus x, which will just be x, and x again. So after you've completed your ice table, you want to set up your equation for K sub C. So that's going to be K sub C is equal to the concentration of your products, which will be the concentration of SO2 times the concentration of Cl2 over the concentration of your reactants, which is just SO2, Cl2. And then you want to plug in the values that you have in your table and the K sub C that's given. So it'll be 2.99 times 10 to the negative 7 is equal to your SO2 and Cl2, it's both x, so it'll be x times x over this that's on your table, which will be 0.195 minus x. And this is where the X's small approximation comes in. So if you look at your K sub C value, and it's really, really, really small, kind of like this is, then you can assume that it won't really make a big change right here when you are looking at the significant figures. So you can kind of just mark this out. And we'll prove why a little bit later. So you can mark that out, multiply this all, so it'll be x squared is equal to 2.99 times 10 to the negative 7 times 0.195, given that your x will be 2.41 times 10 to the negative 4. That's your x. And the question asks what your concentration of Cl2 is. Since Cl2 right here is just x, that's your answer. Okay, so in the previous problem, we figured out that the x for this problem, which is also the concentration of Cl2, is this value right here. And we found this value using the X's small approximation. So to prove that this is actually correct, what we're going to do is make sure that this value is 5% or less of the original amount given. So to do that, we'll take this number divided by 0.195 times 100, and we'll see what answer that gives us. All right, that number gives us 0.124%, which is less than 5, so it all works out.